Bitcoin, a simple explanation. Part 3. Making transactions. Let's say that participant A decides to spend their Bitcoins right now by sending it to another Bitcoin address. Participant C has given participant A an address for him or her to send the Bitcoins to, say address 18YACU, etc. So participant A will now create a transaction on their computer. The transaction will be to send 20 Bitcoins from 1ECKP4, etc. to 18YACU, etc. and send the changed 29 Bitcoins back to 1ECKP4, etc. and give 1 Bitcoin as the transaction fee to be sent to the miner that solves the next block. This transaction will immediately enter the memory pool called mempool, which can be picked up by any of the other miners in the network. Now, let's assume all 3 participants, A, B, and C, continue to try to solve the next block of the Bitcoin blockchain called Block 2. To do this, they would take the current blockchain and then add any transactions they like from the mempool to create a new blockchain that includes Block 0 and Block 1 and Block 2, which is then expressed as a Block 2 computer number. They will then attempt to solve the new block like before. None of the miners are required to add any transactions from the mempool and can continue to mine an empty block if they wanted, but they usually want to add transactions because they will receive the transaction fee that participant A has included in the transaction. So let's now assume this time participant B successfully solves the next block. The Bitcoin blockchain will now look like the following. Block 0, date and time created, plus Block 1, date and time created. 50 new Bitcoin at 1ECKP4, etc. as mining block reward, plus solved hash of Block 1 plus. Block 2, date and time created. 20 Bitcoins at 18YACU and so on. 1 confirmation moved from 1ECKP4, etc. plus 29 Bitcoins at 1ECKP4 and so on. 1 confirmation moved from 1ECKP4, etc. plus 1 Bitcoins at miner's address 14PP4Z and so on. As transaction fee reward moved from 1ECKP4, etc. and 50 new Bitcoins at miner's address 14PP4Z, etc. as mining block reward, plus solved hash of block 2. A real-world example of a solved hash of block number 59346 of the Bitcoin blockchain is shown on the screen. It is a hexadecimal base 16 number containing exactly 64 characters. There is a lot more to all of this, but this is the gist of what Bitcoin mining and solving blocks involves. The entire system has been designed to be very secure and very stable and has been in continuous improvement since it started. A point to highlight is that only so many Bitcoins can be added at a certain time, and the rate of new Bitcoins that can be added is halved about every 4 years. This is where Bitcoin's programmed scarcity comes from and is a major reason why it is so valuable. There will only ever be a certain maximum number of Bitcoins on the planet and never any more. The total number of all the Bitcoins in the world is currently over 90% of its maximum possible number. A final look at transactions. When a transaction is created, the software you use will do a number of things. The most important of these is that it will sign the transaction with the Bitcoin private key, and then it will broadcast the transaction to the network. The way your computer proves to the network that you are the rightful owner of the Bitcoins stored at a particular Bitcoin public address is by using one-way hashes together with your Bitcoin private key. And it does this without revealing your Bitcoin private key to anyone except yourself. To picture how this is possible, simply go back to our previous example of how your Bitcoin private key was hashed to create the Bitcoin public address. Now, instead of random number, then creates Bitcoin private key, then uses one-way hash to create Bitcoin public address. We simply add one more hash step in between the Bitcoin private key and Bitcoin public address so that we have random number, then creates Bitcoin private key, then uses one-way hash to create signature, then uses another one-way hash to create Bitcoin public address. Now it is possible to show the network your signature without revealing your Bitcoin private key while still proving that you are the owner of the Bitcoin private key. In practice, there is more to the signing process, such as public keys, and each signature will only work specifically to a particular transaction you have created. But you get the idea. As soon as you have created the transaction and the Bitcoin network has checked that it is valid, your transaction will enter the mempool in order to be picked up by a miner and then eventually added to the next block of the blockchain. Bitcoin transactions, therefore, can happen securely and discreetly with no need for you to trust any particular third party, such as banking institutions. You only need to trust that your own creation, storage, and transaction steps used to create and send the Bitcoins were secure, and that the network of miners maintaining the network will continue to mine new blocks the way they have always mined them since the very beginning. I will now explain all the slight inaccuracies in this video series. Inaccuracy 1. At 2 minutes, 50 seconds of part 1, I said, all Bitcoin private keys start as a very large and very random number that is created by the Bitcoin computer wallet program. This random number might be between 100 to 1,000 numbers long or longer. The fact is, the actual random number only needs to be between 2 to the power of 128 and 2 to the power of 256 to meet unbreakable cryptography standards. This is roughly equal to a number containing between 39 and 78 decimal numbers. Inaccuracy 2. At 27 seconds of part 2, I said, the Bitcoin blockchain is maintained by a large number of highly invested people and groups who take part in the network, known as miners. The correct fact is, not every miner who takes part in the Bitcoin network needs to be highly invested. Many smaller miners who work as part of a larger mining pool have not necessarily spent huge amounts of money on their equipment. Many mining groups, however, are heavily invested and they are located all over the world. Inaccuracy 3. At 44 seconds of part 2, I said, the easiest way to understand the Bitcoin blockchain is to go back to the very beginning of Bitcoin in the year 2009 at block 0 known as the Genesis block and then slowly build up from there. I want to emphasize that these things didn't happen as described for the actual Bitcoin blockchain, but is rather a hypothetical scenario which fairly accurately explains how Bitcoin mining and Bitcoin transactions work. In reality, the real Bitcoin blockchain was originally mined mainly by its creators, Satoshi Nakamoto, for a period of up to 12 months before any significant number of other participants joined the network. The first block was mined on the 3rd of January 2009, and the first open-source Bitcoin client or program was released to the public on the 9th of January 2009. The first Bitcoin transaction was made on the 12th of January 2009, about 10 days after the first block was mined. The huge majority of the estimated 1.6 million or so Bitcoins, which was mined in 2009, have never been moved, and it is believed that the private keys to these have been lost. And lastly, inaccuracy 4. At 4 minutes 27 seconds of part 2, I said, every 2 weeks, the difficulty of the hashing algorithm is automatically adjusted by the Bitcoin computer program which all the miners run. By adding or reducing the number of consecutive zeros that are needed before new Bitcoins can be awarded. The more zeros there are, the more difficult it is to solve. The way the actual Bitcoin mining difficulty is set is not by requiring the hash number such as 0, 0, 0, 0, etc., 1, 4, etc., to have a certain number of consecutive zeros in front of it, but for it to be smaller than a certain number that happens to have a lot of consecutive zeros in front of it. So for the above example, the hash number might just need to be a number smaller than, say, 0, 0, 0, 0, etc., 1, 5, etc. Because of this, the difficulty can be set quite precisely. And that concludes our video series. Note, this video series has been narrated by a professional voice-over artist. It has not been narrated by the author of the original article.